Let me know if this sound is good. Okay, perfect. So welcome to our session today. I know you guys are getting so close to wrapping up on June 19th, so that is very exciting. Today we're going to walk through the series and parallel circuits activity. It is, again, not required for a teacher graded assignment, but you will see questions come up on quizzes and tests about it. So I want to make sure that everyone has a really good understanding. My normal slides did not load with it, so I'll remind you guys as we get started. Just remember not to exchange any personal information, and you're able to use chat as we go. And then just a reminder that our objective for the day is just to cover the lab activity and get the information out of it. And I do have a couple of videos to show you in case you aren't able to do this experiment on your own. And then we'll take a look at the questions that go along with it just really quickly. And then I have a quizzes for you guys. So I think you will enjoy the session. So we'll get started. You definitely want to be able to identify the difference in an open and closed circuit. We also call those series and parallel circuits. So make sure you have notes on this. I always encourage you to have those. Use them on your quiz, use them on your test. All right, so we'll start out really quick with a word search. So are you guys able to see this enough? I know it gets blurry when I paste it on a screen, but can you guys see it enough to use the whiteboard tools to see if we can find some of these words? I'm going to set a timer for about 3 minutes, and we'll see how far we go. I mean, we've not done that all year long. So our timer's going, so let's see really quickly. We'll see what that does. Awesome, you've already found one. I'm having to look super close because it is kind of blurry. All right, I found volt. Turbine or turbine. I found wire, but I don't see that as a word. It should be a word, right? Oh, I found switch. We have just a few more seconds. All right. Yeah, I know that is hard for your eyes, so great job on getting started with that. All right, so as we move in, we're going to take a look at a quick video. It's a Bill Nye, so you know that might be a little bit older, but Bill Nye is always really funny. So we'll take a look at his video on circuits. Oh, it wouldn't let me share that link. Hang on, let me get another one. I must have picked up part of another link. Try it again. All right, let me know if that plays for you guys.
In the mid-1700s, Ben Franklin figured out the nature of electricity, paving the way for many more inventions. Electricity provides a way to store and distribute energy generated in a variety of ways. We live in an electric world. Electricity flows through us and around us. It dances in the sky as lightning and pulses through our bodies as signals between the cells and organs. We are always finding new ways to use electricity.
All right, guys, I am going to stop us there. I know we have about another minute left, so the link is in chat if you want to watch the rest of that a little later. But we're going to go ahead and take a real quick look at some of the points in the lesson just so you understand for sure the difference in the types of currents and what a circuit is. So if you're taking notes, just remember that a circuit is a continuous loop of electric current. All right, so remember these three parts. You may want to draw this in your notes. You've got the electron source. Basically, that's what's providing power. That's the battery. You have the electron loop, and that is the wires that make the loop so the electron can travel. And then the resistor. The resistor is the light bulb or another device that converts some of that energy from the circuit into light or thermal energy. So you have three parts. You can see them here. I know resistor always kind of confuses people, so definitely having that in your notes is helpful. And then identifying an open and closed circuit, and that is kind of how you work with the series and parallel circuit lab. So electric current will only flow if the circuit is closed. So this is the beginning of how we understand series and parallel too. So if you look at the closed circuit, you have a battery, and this is such a simplistic drawing, but you can see the flow of electrons, and it's just moving, it's closed. For the open circuit, you see there's one part, there's a switch. So this is like a light switch in our home. We have an open circuit. We're able to turn it off and on. When we want to break that connection, we're stopping the current so we can turn the device, the power, off when we don't need it. Okay, so that's the difference in open and closed, is the ability to break the circuit to stop the flow of electrons. And then when you get into series versus parallel, you have a series circuit. The current flows through the resistor or the light bulb. So if you look at the picture here, kind of try to imagine that electron flow. So it goes to a conductor that leads to the next bulb all the way down the line. And then in a parallel circuit, you're able to see that the current can follow multiple paths. So what I try to remember in a series circuit, I remember series and single, like a single wire connecting those. And then in a parallel circuit, if you remember what parallel lines look like, you know, they run like, you know, above each other or something. So there's two, and that's how I remember parallel being like two wires. All right, so in the activity, it asks you to get some things out of your kit, and then I think some of them are just home items that you might have. So you have batteries, a battery holder, small wooden block, a light bulb, light sockets, paper clips, screwdriver, thumbtacks, copper wire, and a wire stripper. And I'm going to show you this quick video. This is just a video of a guy building a series circuit and a parallel circuit. So if you weren't able to do that lab, you can watch the video and just see how all of this was put together. So we'll take a look. We'll watch the whole video. It's a little bit long, but you're able to see how he builds both of those.
Hello, today we're going to be dealing with series circuits and parallel circuits. And we're going to actually build one of each circuit today and just give an example of how one of them is simpler.
All right, guys, I know that was a little bit long, but I wanted you to be able to see that just in case you weren't able to complete that activity, you could get a visual understanding of how that worked. So the next thing that we can talk about really quick is when you look at investigating errors. So when conducting investigations, you can make errors. Errors in the experiment can lead to wrong data. So in this experiment, it's asking what could be the possible sources of error. So a couple of things. One, the circuits may have been wired incorrectly. the battery or bulbs may not have been working properly, or you could have different voltage batteries that may have been used. So those are a couple of things to look at. Really quickly, we'll go through these questions. Again, they are not submitted for grading, so it's just comprehension and understanding. You guys feel free to chime in on the chat, and then we can hopefully get to our quizzes. If not, I think I can send it with you to go. So what's the voltage source? What's always the voltage source when we are asked that question? What are we looking at? The battery, yes. That's our power source. That's where we're getting the power. So is it realistic to think that the electrons will flow through the circuit forever? Do you think they would flow forever? Yes or no? No, you are right. So those of you that put no, you're right. What are possible reasons why not? Batteries, they run out of juice, right? What about light bulbs? Do they last forever? Nope, they don't either. And sometimes even wires. Yep, you're right. The filament breaks, and the wires could eventually wear out too. So they would not flow forever. All right, so when we're looking at open and closed, remember that's off and on. When did the series, or I'm sorry, not series, when did the circuit become closed? Oh, I know, I hate when lights go out. I have bulbs out right now too I need to get. All right, when did the circuit become closed? Right, so it's closed when all the wires are connected and the light is lit. But when you open it, what happens? When you open the circuit, that means like maybe we take a wire off or we turn something off. What happened? Right, something was disconnected, the light would go off. You're right, the electrons could not flow. You're exactly right. So now talking about specifically series and parallel. He talked about Christmas lights, holiday decorations in the video. So think about those lights of, if the light's on, if they were a series circuit, what happens when one bulb goes out? Do you guys remember what he said? All of them, yes. And then a parallel, we know the difference is only one, right? And that is a good thing. Okay, so think about this. When one of the bulbs was removed from the series circuit, what happened? Same kind of deal. He took one bulb out of that series circuit, and all of the bulbs went out, right? And then in the parallel, he was able to remove even two bulbs, and they all still, the one bulb left still worked. So that's the important thing to remember there. When one of the bulbs was removed from the parallel, we just talked about this, the others were still lit. Okay, the other question is you're comparing these circuits, so a series circuit with one bulb and a series circuit with two bulbs. Do you remember what he said when we were looking at how bright the light bulbs were? Which one had the brighter lights? So remember, he used the same bulbs, same batteries, but he had two wires on, right, the parallel. So the two wire, the parallel circuit, those were brighter than the series. Great. And this is the last one. When all the bulbs, oh, and we just answered it, parallel or brighter. They did illuminate equally, and they were brighter than the series circuit. All right. So let's go to quizzes really quick. If you have to go, you can definitely take off. Let's see. If you want to stay